Hello everyone, welcome to my channel Cryptoware, and we are going to start a series which is understanding various tools that is required during malware analysis. So the first tool that we are starting with is Wireshark. So this is my Remnux VM. So your Wireshark can be run in Windows, in Linux, anywhere, and it is an open source tool. So you can download it from their official website. So let's start. Let's open Wireshark. So here you can see that it is talking about various interfaces. So what do you mean by such interfaces? Like in your host machine, you see how you're connected to the internet or to any kind of network, right? So how am I connected to any network over here? So you can choose any of them. For simplicity, I'm using any. So from whichever interface, if any kind of network packets come, it will get captured over here. Now, what do I mean by network packets? So, network packets are nothing. They are just like unit of data of uh, of how a transmission is happening between source and destination. So, basically, it is capturing any kind of data. Uh, for example, let me show you. Give you an example. So suppose here I am doing ping 8.8. So we see that it is getting captured in the Wireshark. Let's close it for now. Let's start understanding from here. So first thing first, Wireshark is a sniffing tool. So it passively sniffs. So if I am sniffing a, an entire network, suppose, the other tools or any device or anyone will not come to know about it, hence the term passive. What happens with active sniffers? You are aware that okay, somebody is capturing my packets or sniffing my packets or whichever networking that I am doing. So here nothing happens here. The user is mostly unaware. I'm not talking about myself, but the other users within a network, they're unaware if their packets are getting captured. Okay. So here I sent a ping command. Okay. 8.8.8.8. We know that this is an ICMP protocol that it is using. So here what we can see that from this specific IP, this is the source, this is the destination, and ICMP request was sent, a ping request was sent. So here we can see that there is a request, there is a reply. Okay. Some more packets are getting captured since I had chosen any. So any kind of networking that is happening currently at my VM, all of them are getting captured over here. So let me just stop capturing the packets. So from here you can stop capturing the packets. I can start capturing the packets from here. You can capture from here also. There are other options also. There are various filters as well, what kind of filters that you want to use, various things. We will get into all those things gradually, not now, but we will get into it while analyzing various samples and going through various networking packets. We will definitely go through all these things and we'll learn about them. So now here you can see, let's select this packet, source and destination. So what I'll do is I'll just right click and go to follow. So there's nothing over here. Let me just do one thing. Yeah. So I double clicked on it. So now if you're aware of the networking basics and of all the layers, not the OSI 7 layers, I'm talking about the TCP IP layers, which is that is practically used. If you're aware of that, you can see how each layer is involved over here. So what is happening in each layer? So what happens? ICMP protocol is being used, echo ping request, code is 0. So every protocol has a type. So this is specific to ICMP. So if there was supposed to be some other protocol, then we would see some other kind of information related to it. It's not like suppose we are using some other protocol, for example SMB or HTTP, and you're expecting that some type or code, such kind of options would come. It is not necessary to have those kinds of options for all the protocols. Each and every protocol is defined differently. So here you can see destination address, source address, protocol, as I mentioned. Some flags are mentioned. So how do they define what to do, how to send the request, what happens, how is it being sent? All these things, all these details, and much more than that are present over here only. So here you can see some encapsulation type, Linux cooked mode capture v1. So you can see interface name any, all kinds of information is mentioned over here. Another thing that we can see, this is something that you need to explore by yourself. I'm just giving you a, a start from where you can, you know, get ahead or go ahead with the Wireshark. And anyway, we are going to use these tools later on, and I've used previously as well, but not for a longer period of time. So few other things, that there is a filter option that you saw just now. So we can also look for specific IP address. For example, I pinged 8.8.8.8. So I can just mention IP.addr and just filter it out, and I can look for whatever packets are present related to 8.8.8.8. Suppose I remove the current filter and I want to choose something else. Okay, so I see that there is DNS protocol. Suppose I just write ip.addr. So where this would be required. So suppose you are analyzing a sample, malicious sample that is trying to connect to a CNC server. So in that case, you are looking for various connection that your machine or your device is trying to make to an external IP or a URL. So through Wireshark, you'll be able to first of all identify those external IPs or URLs. You may be able to identify if it is CNC. If it is CNC, you can simply filter it and then figure out, and you can see all those packets from where you can actually identify what is happening over here. Okay, so it's DNS. Suppose I do double click over here. So here also I'll see some more details. So here is UDP. As I mentioned, if your protocol changes, all other options that are present are, and are specific to that protocol will also change. Domain name system. So you can see there are other flags over here, some other information mentioned over here. So if you are quite decent with the networking, with the basics of networking, you'll be able to understand what is actually happening. And for I would suggest for cyber security, basically networking is the core. One should know networking very well, understand networking very well, how you can capture packets, how to identify and analyze those packets, what can be done in those cases. This, it would be very helpful in those scenarios. Another thing that I would like to mention is Wireshark is like if there is some encrypted data which is being transferred from one source to destination, then you won't be able to see that data. So it's not necessary for you to be able to see all the data. You can see the packets, how is it being transferred, but the encrypted data cannot be seen. It will show you as it is, as the data is being transferred or transmitted from the source to destination. So if you want to save the packets. For example, you want to analyze these packets later on. So when will you require it? Again, if you are analyzing some sample and you see some CNC or some external IPs or URLs, you can select all those packets that you are seeing that you want to analyze later on, and you can export the specified packets. But before exporting, you should make sure that you have stopped capturing the packets, otherwise you won't be able to see the option. So you can export the specified packets. You can export it as pcap ng or pcap, anything. TCP dump also works in the same way. So any extension of your choice, you can name it, you can name the file, and then you can simply save it. You can select it packets only, you can choose here. So this is as simple as that. Okay. So for now we are just learning, or we have just started with understanding and learning about Wireshark. Later on we'll start with analyzing some malicious samples, which from where we can actually analyze some networking packets and understand, yes, it is performing some malicious activity as well. So that's it for today. Thank you so much. Please like, share, and subscribe to my channel, and see you in the next video.